In the previous lecture, we had seen the SAS rule for the congruence of triangles. Let us quickly recall what it was, and then we'll proceed to discuss the next rule to prove the congruence of two triangles. If you recall that if only one side of two triangles is matching, so for example, these two triangles where only one of the side is matching with having a length of 3 centimeters, but the other sides are not having the same length, then we saw that those two triangles are not congruent. Similarly, we have seen that if one angle and one side of two triangles are equal, even then the two triangles are not congruent. As you can see from these pictures, both these triangles have one angle 60 degrees and one side equal, but the two triangles will not fit on top of each other without exposing or revealing some part, right? So therefore these two triangles are not congruent. But when we have two sides of the triangles are equal and the angle between those two sides is also equal for two triangles, then those two triangles are said to be congruent, and we call this rule as the SAS congruence rule. So we have one side 4 centimeter for one triangle and a similar side of 4 centimeters on the other triangle. Similarly, there are two other sides in the of the two triangles which are equal, and the angle between those two sides, which is called as the included angle, is also equal for the two triangles. So therefore these two triangles are congruent, and it's called as the side angle side rule, SAS rule. So there's a side, there's an angle, there's a side, and the angle is between the two sides which are equal. So that's why you see here the angle A is between the two sides. It's in between the two sides. In that case, the triangles are congruent. Now let us take this case where the angle is not included between the equal sides. In that case, is it still going to be congruent or not congruent? So if the two sides and one angle of two triangles are equal, but the equal angle is not included between the two sides. So you see here, there is a side of 5 centimeter and 4 centimeter. Similarly, there is a side of 5 centimeter and 4 centimeter in these two triangles. But the angle which is equal is not between the equal sides. So this angle here is 90 degrees and this angle here is something else. The equal angle of 50 degrees is not lying between the equal sides. It's not between the 5 centimeter and the 4 centimeter side. Similarly, this 50 degrees here in the second triangle is not between the 5 centimeter and 4 centimeter sides. So the angle is not included between the equal sides. In this case, can we say that the two triangles are congruent? If we try to fit these triangles one on top of the other, they will not cover up each other. So we say that this is not going to be congruent. So the answer for this, are the two triangles congruent when two sides are equal and one angle is equal, but the angle is not included between the equal sides? In that case, the triangles are not congruent. Okay, so what we can say is that this is the case where we have a side and angle is equal. So this is SSA rule. We can call this as side angle. Similarly, we can call this a side angle. So this is SSA, or we can also write this as angle side. Let me write that, or angle side. Similarly, for this one, we can write as angle side, or angle side. Okay, these are not acceptable conditions for congruence. So these are only SAS gives us congruence, but if the angle is not between the two sides, so you see here, the angle is not between the two S's. The angle A is not between the two S's. The angle A is not between the two S's, right? In this case, it is not congruent. So SSA or ASS do not guarantee congruence of two triangles. Only SAS gives us congruence. So we have seen here the example which we started in the last class, where two sides are equal and one of the angles is equal, and we have shown now that the equal angle must lie between the two equal sides. But what happens if we have two angles are equal and one of the sides is equal? That's the next condition we are going to see. So this is called as the angle side angle rule. So we have two angles are equal and one of the sides of the two triangles are equal, and in this case, is it congruent or not? We will show that they are congruent. So if two angles are equal, so there's an angle of 60 degrees, another angle of 60 degrees in the second triangle, there's an angle of 40 degrees in the first triangle, an angle of 40 degrees in the second triangle, and the side which lies between the two angles, so there is a side of 4 centimeters and 4 centimeters in the second triangle, and you notice that this side, which is having equal length in both the triangles, is lying between the equal angles. So it is lying between the 60 and 40 degrees. So we have angle side angle, angle side angle, and if we put one of these triangles on top of the other, clearly they will cover each other, and this is called as the angle side angle congruence rule. So if there is one side which is equal and two angles are equal, then the two triangles will be congruent. So let us prove this with an example. So let's take an example of two triangles ABC and another triangle DEF. Okay, triangles ABC and DEF. We are given that two of the angles in both of them are equal. So angle B is equal to angle E, angle C is equal to angle F, and the side between the equal angles, which is BC, equals EF. This is given to us. We need to prove that these two triangles are congruent, and to prove this, we can use the other rule that we are already familiar with, which is the SAS rule. So the first condition that arises is, given that we have these two angles equal for both the triangles and the included side also equal, we can have a second side, we can take it as equal or not. So let us first consider the first case, where another side, which is the side AB, and another side of the second triangle, which is the side DE, let us consider them to be of equal length. If these two are equal, if AB is equal to DE, that means we are saying that this side is equal to this side. In this case, are the triangles congruent or not? So AB equals D, we have, that is our consideration. We have angle B equals angle E, so that's our given condition, and we have BC equals EF, that's also a given condition. The base of the triangle BC equals the base of the second triangle EF, so that is nothing but we have one side equal, one angle equal, and another side equal, so that is the SAS rule. So therefore, for congruence, so therefore the two triangles, triangle ABC is congruent to triangle DEF. So congruence is proved by the SAS rule. When we consider the side AB to be equal to the side DE. Now, what happens if we consider the side AB to be not equal to the side DE? So maybe AB is longer than DE, or maybe AB is shorter than DE. So we look at those two cases, and we will eventually show that even if we consider AB not equal to DE, it will eventually be proved that AB will have to be equal to DE, and therefore the triangles will remain congruent, because if it is congruent by this rule, okay, if these two triangles are congruent by this rule, they should be congruent, and we'll come up with the valid argument for that as well. So we go to the second case, where we consider that the length of AB is greater than the length of DE, AB greater than DE. So in order to prove the congruence of these triangles, or to check this, what we should do is we have to take a point P on AB. So we'll take a point P on AB such that PC becomes equal to, so I'll mark this line. So PC is equal to DE. So we'll mark this point as P, not PC. We'll mark the point P such that PB becomes equal to DE. Okay. So let AB equal to greater than DE in this case. Because it is greater, we'll take a point P on AB such that PB equals DE. In this case, we will consider now whether the two triangles PBC are triangles PBC, triangle PBC, and triangle DEF congruent. So again, because we have taken the point P on AB such that PB is equal to DE, PB equals DE, and we have angle B equal to angle C and BC equal to EF. So by SAS rule, the triangle PBC and triangle DEF will be congruent when the case of AB greater than DE, right? So to check this, to prove that these two triangles are congruent, so we have PB equal to DE, angle B equals angle E, and BC equals EF. So this is again side angle side, so congruent by SAS rule. So we'll write by SAS rule, triangle PBC is congruent to triangle DEF. Okay, now because triangle PBC and triangle DEF are congruent, we can say that the angle which is here, the angle PCB must be equal to angle DFE, that is by CPCT. So let me write, put a line here. Since the two triangles are congruent, by corresponding parts of congruent triangles, CPCT, angle PCB must be equal to angle DFE. Alright, because these two triangles now we have shown that congruent when PB is equal to DE. So but we are given in the question that ACB is equal to DFE, but it is given that angle ACB equal to angle DFE. So we have two relationships here. One says that angle PCB equals DFE, and the other says that the given condition where we started off says that angle ACB is equal to DFE. So how can PCB and ACB both be equal to DFE? If they are both equal to DFE, that means PCB and ACB angles are also equal. So therefore angle PCB equals angle ACB. This can be true only when the point P coincides with A. So that means the condition that we considered AB greater than DE is a wrong consideration, is a wrong assumption. We assumed here that AB is greater than DE. Based on that assumption, we are concluding that PCB and ACB are equal, the two angles are equal. This can be true only when the point P is exactly on the point A. So that means PB must be equal to AB. So that means point P lies on A. So therefore, point P lies on point A. Let me write that clearly. Lies on point A. So we are clearly seeing that our assumption that we have taken AB to be greater than DE is incorrect, because if we take that assumption and then consider the point P to be on the line AB such that PB is equal to DE, then we end up with this relationship which proves that the point P actually lies on the point A. So that means AB equals DE. Okay. Similarly, we can prove the other way around when AB is less than DE. Suppose we take that the line segment, the side of the triangle AB is smaller than the side of the second triangle DE. We can take a similar argument here where we'll take a point P on the second triangle here. So we'll take a point P here and make a triangle here. Okay, now we have a triangle PEF, and if we try to prove the congruence of triangle PEF with triangle ABC, we'll have similar arguments as in the previous case. So take a point P, take point P on triangle D, not on triangle D, on side DE, on side DE, such that PE equals AB. So for triangles, for triangle ABC and triangle PEF, we can check whether they are congruent. So we'll have AB equals PE, angle B equals angle E, and the base is the same for both. BC equals EF. So again, that's a side, that's an angle, that's a side. So by SAS, these two triangles are congruent. By SAS, triangle A, not angle, triangle ABC is congruent to triangle PEF. So these two triangles are congruent. So ABC is congruent to PEF. This triangle which we have constructed with this dotted line, these are congruent. But now if we look at the angle by CPCT, so by CPCT, that is by CPCT, we can say that angle ACE equals angle PFE. But it is given to us that, but given angle ACE is equal to angle DFE. So we see that angle AC equals PFE and AC is also DFE. That means PFE and DFE must be the same. Angle PFE and DFE the same can happen only when the point P lies on point D. So this can be true only when, that is, point P lies on, let me write the other statement first, that is angle PFE is equal to angle DFE. Therefore the point P lies on point D. So therefore our assumption that AB is shorter than D is also wrong. So therefore the triangles ABC and DEF are congruent when we have two angles are equal and the included side between the two angles are also equal for two triangles. The remaining sides and angles will also be equal, and therefore the two triangles will be congruent. However, unlike the SAS rule, the angle side angle rule, right? This is the angle side angle rule. The ASA rule does not require the equal side to be between the equal angles. Okay, for the ASA rule, it is not necessary that the equal sides of the two triangles are included between the two angles. So that means that we can have the equal side on the outside of the equal angles as well. So we can have AAS or SAA conditions to prove congruence. But if you remember, for the SAS, the angle has to be between the two sides. But for the ASA, the side does not have to be between the two angles. The side can be on the left or in the first position or in the last position, or in the middle also between the two angles. In all three cases, the triangles will be congruent. But for SAS, the angle has to be between the two sides. If the angle is in the beginning or in the end, then that will give us ASS or SSA, and these conditions do not guarantee us congruence. I'll stop here and we'll do the next set of rules for congruence in the next video.